So for this chapter, we're doing part of chapter 3, kind of out of order. So we'll just kind of go with it. So lesson 3.3 is translations of data. So let's say you have a restaurant that employs 11 workers, and these are all the daily earnings. So if we put all that in a spreadsheet, and keep in mind 60, 66, 67, 68, 70, the rest of this is underneath, you just can't see it. And we'll add lists in spreadsheet and go in there and do that. We'll talk about that in a second. Suppose that on a particular day, the host of a large party gives a tip of $110 to be divided evenly among all the employees. Since there's 11 workers, 110 divided by 11 is $10, so each employee gets $10 added to their wages. So then in terms of a translation, if we're assuming every wage is an X value, every wage now goes to X plus 10 because $10 is added to each one. So then we're going to make a new column. So let's go through and do this. So if we go to home, add lists and spreadsheets to new document, just click the one that looks like a spreadsheet essentially, and we'll call this wage. I'll put the wages in there, which was 60, 66, 67, 68, 70, another 70, 3 72s, a 73, and an 80. I'll go back up to the top and we'll call this one new. It's really just like the new wage, and then we'll click equals A, because that's column A, plus 10. And you'll notice those brackets appear automatically. And so now we have this column, and this is every single wage with 10 added to it. Then what we'll do is we'll use the stat calc feature to find statistics. And all the steps are here, but I'll show you as well. So you go to Menu, Statistics, Stat Calculations. Oops, sorry. Let's go back. Sometimes it clicks automatically, right? So we want to click on that. And then we'll go to Menu, Statistics, Stat Calculations, and then we want one variable statistics because we only have one variable involved. Number of lists, we have 1. For our X list, we want B. We want that second column with the new wage plus 10. First result column is C. Basically, we just don't want to overwrite anything we already have. So then what we have is we see all this information here. So we have our mean that's 80. So if we go down here back to our notes, for our translated data, which is what we just found, the number, and this was not 70, we had 11 pieces of data, and then we added 10 to each one, we still have 11. If we look at our calculator, it looks like now our new mean is 80. Median, if we scroll down, median, where is it? There's median X, so the median is 80. The mode we actually just have to find by hand. So if we look at our data here, the most common value that we had was 82. Okay, if you just look at the list. Oops, there it is. 80, 82. The range, well, if we look here, I know my minimum is 70. And my maximum is 90. 90 minus 70. So our range, 90 minus 70, equals 20. Our standard deviation, I think I went past it. C and S. That's the sum. Variable statistics. Let's look down. Oh, there it is. SX, that's 5. Okay, because we're talking about sample standard deviation. And so just to review, N was fine, mean was X bar, median you found, mode was the most common value. We kind of talked about this, but and to find the range, you have to do the max minus the min. Standard deviation, we're talking about a sample, so we'll do S, variance is S squared, IQR is Q3 minus Q1. Okay, so back to the calculator for a second. Our SX is 5. So then our standard deviation is 5. Our variance is just S squared, so 5 squared, which is 25. Oops, sorry, I was clearly listening to Taylor Swift's Evermore. Big fan, highly recommend. And then IQR, if we find Q3 is 82, Q1 is 77. So then IQR is 82 minus 77, which is 5. And now normally I would have you do this with a partner on your own. Basically, if we look here, the number of values, is there a change? Well, no, if you add 10 to every value, you still have 11 of them. The mean, that changed. We added 10, right? We added 10 to all the values. The mean went up by 10. Same with the median. We went from 70 to 80 when we added 10 to each value. We added 10 to the median. Same with the mode. Range, that stayed the same. It was 20 regardless. Standard deviation stayed the same. Variance stayed the same. IQR stayed the same. So if we look at the box plots, basically what happened is the mean, median, and mode all moved, but the measures of spread remain the same. So basically this blue box plot, we kind of just slid it over. So the distances between, Q1 and Q3, those distances stayed the same. The spread stayed the same. We just picked up the whole plot and moved it over by 10. And so this is a theorem for centers of translated data. I don't care that it's a theorem, but know that if you add to each number in a data set, it adds H to the mean, median, and mode. So there was a change, delta for change. For spreads of translated data, again, the fact that it's a theorem, who cares? But this is a fact about this data. If you add H to each number, it does not change the range, interquartile range, IQR, variance, or standard deviation. So the centers change, mean, median, and mode. The spreads do not change, so no change. So if we look at this example, basically we have a local produce store. Cantaloupes sell for 99 cents a pound. A clerk weighed 30 melons and computed all these statistics, the mean, standard deviation, median, and IQR. After finishing his task, the clerk noticed that the scales were not correctly calibrated. Oh no, this is so terrible. The scale was set at 3 ounces as its starting weight, not 0. And we have to find the correct values for the mean, standard deviation, median, and IQR. And basically what this means is the scale was 3 ounces too heavy. So for the values that change, we'll have to subtract 3 ounces to make it accurate. However, if it was just, we have to subtract 3 ounces from all the values. If we look at it, well, the mean, that changed, right? Standard deviation, that doesn't change. That's a measure of spread. Median changes. IQR does not change. Okay, so if we find the values for these, our mean, before it was 56, so we'll subtract 3 and get 53 ounces. Our standard deviation was 8. It doesn't change. It's still 8 ounces. Our median was 58. Our median did change. So we subtract 3 and we get 53. No, sorry, 58 minus 3 is definitely 55, not 53. And then the IQR did not change. So the IQR is still 16 ounces. Pause the video and try example 1B right here, okay? All right, I'm assuming you tried it. So at an MMA tournament, I'm not sure what that stands for. You can Google it if you're super curious. The 20 fighters weighed in before the tournament, so I guess it's some sort of fighting. All the fighters made weight, and a statistician compared the statistics The mean was about 191, standard deviation was almost 30, median about 195, IQR about 35.5. And then the statistician realized that she made a mistake. Oh no, or it wasn't calibrated correctly. So the starting weight was set at 0.25, not 0, meaning that we have to subtract 0.25 pounds from all the values. Okay? And this is the same general process. Basically, we know the mean will change, standard deviation will not change, median will change, IQR will not change. So our mean, it was 191.125. If we subtract 0.25, 191.125 minus 0.25, we should get 190.875 pounds. Standard deviation, 29.7. It's still 29.7. The median, so the median we subtract, it should change. So the median we should subtract 0.25, so we get 194.25 pounds. IQR doesn't change, so the new IQR is the same as the old IQR, which is 35.5 pounds. Just to recap a little bit, basically if you add or subtract something to each number in a data set, the mean, median, and mode, they change by that same amount. However, if you add or subtract a value to each number in a data set, the range, interquartile range, variance, and standard deviation do not change because the look of the graph stays the same. It just shifts over by whatever you added or subtracted from each value.